Hello learners, welcome to Manifested Publishers e-learning portal. In our today's session, we are looking at costs of production or theory of costs. So theory of costs can be looked into two perspectives. We normally have the long run and the short run. So I'll begin with the short run analysis of costs. Short run. So short-run analysis can be looked into two perspectives. We have the long run and the short run. So I'll begin with the short-run analysis of costs. In the short run is where at least one factor input must be fixed. Fixed means when the market conditions change, that factor will not change. So like, for example, when we are changing the level of output from one level to another, a fixed factor will not change. It will remain the same regardless of the level of output that you are changing. And a good example is something like rent. Like when you have rented a premise and then you are using that premise for your business purposes, the time you are not using that premise, whether you use it or not, you will still have to pay rent. So meaning at zero level of output, fixed cost or fixed input factors will still be incurred. And then the time you use, it does not matter the level of usage. The more you use, still that input factor will remain the same. So we can define it. What is a fixed input factor? What is a fixed input factor? This is a factor which does not change or vary, with the level of output. So it remains the same. Graphically, if we are to present a fixed factor, this is how it will look like. So this is a fixed cost. So this is the level of output, which is in units. And here we are talking of costs. So we begin from zero output. So when you are producing zero output, a fixed cost will still be incurred at this point. Even if I increase my output to 1, to 2, to 3, and so on, that cost is remaining constant at all levels. And that's what we refer to as a fixed factor or a fixed input factor. Then number 2, we have variable input factor, which is also a variable cost. So a variable input factor is that which varies with the level of output. So that simply means when we are changing the level of output, that factor will change in the same proportion. The time we increase, it will also increase, and the time we decrease, it will also reduce. So to illustrate this graphically, this is how it will look like. We have output, which is in units, and then we have costs. So a variable factor will look like this. This is total variable. So we are beginning with the zero output. So at the time I produce 1 unit, the cost will not be the same. It is rising. The time I increase my production, the cost is also increasing and so on. So if this is 1, this is 2, 3, and so on, the time you increase, it will also increase, and that's how it continues. We also have what we refer to as total cost. Total cost. This is the sum. This is the sum of fixed and variable costs. So how do we illustrate this? This is how we represent a variable, a total cost. So we have 0. This is output level, which is in units. And then we have cost. So the costs here are fixed costs, total variable cost, and total cost. So we have a relationship between this cost. We are saying that total cost is simply the sum of the fixed cost and the variable cost. So these fixed costs are those that are remaining constant, and then the variable are those which are changing in direct proportion with the level of output. So when we take fixed costs plus variable cost, it will give us a sum which we are referring to as total cost. So how do we derive these curves? We have a relationship between total cost curves, total variable cost curves, and fixed cost curves. So what is the relationship? The total cost curve is drawn based on the law of diminishing returns. So what happens is, like when total variable costs are rising, initially we do not have any cost that is incurred. The only cost that is being incurred here is a fixed cost, which is remaining constant. So when we have 0 output, where we have 0 output, so that means no output is produced, fixed cost equals total cost. Where there is 0 output, fixed costs equals total cost. But the time variable costs begin to rise as the level of output changes, then total cost will begin to rise. So at the time variable costs are continuing to rise, the total cost will continue rising. And therefore, total cost curve can be explained by diminishing or increasing returns to the variable factor. And this variable factor is that which is bringing about the level of change. So it normally increases or it decreases depending on the factor, variable factor. That means when the variable factor is decreasing, total cost will decrease. But when the variable factor is increasing, total cost will always increase. So that when we take fixed cost plus variable cost, we'll be able to get what we are referring to as total cost. We have other costs again which are associated with the short run, and we have what we refer to as average fixed cost. Average fixed cost. Average fixed cost. So what is average fixed cost? Average fixed cost is simply the fixed cost per unit. Fixed cost per unit is the fixed cost per unit of output. And so that simply means to calculate or to get average fixed cost, which can be abbreviated as average fixed cost, we simply take the total fixed cost and then we divide by output, which is indicated by Q. So we say where Q is simply referring to output in units. And graphically, how do we represent this? This is how it will look like. So we have output in units. Then we have costs. We have an average fixed cost. This is the average fixed what? Fixed cost. So we say this curve is continuously falling, but even as it falls, it is not able to touch or to reach both axes. So we say it is asymptotic. Asymptotic simply means though it is falling and it seems to be reaching the x-axis, it can never reach the x-axis. That is the average fixed cost. We also have another one known as, this was our number 1, number 2. This is number 3. I can call this number 4. So I can use this space. So we move on to number 5. So our number 5 cost is average variable cost. Average variable cost. This is the variable cost per unit. So mathematically, we say that average variable cost equals total variable cost divided by output in units. So we say that where Q is referring to output, which is in units. Graphically, it will be as follows. So this is output in units, and these are costs. So this will be our variable, average variable cost. The cost curve is U-shaped. So we'll explain why it is U-shaped. It is U-shaped simply because of the diminishing returns to the variable factor. And then we move on to the other cost, which is average total cost. Average total cost. This is our number 6. Average total cost, which is simply the total cost per unit. Or is average fixed cost plus average variable cost. So it is equal to this total cost. Average fixed cost plus average variable cost will give us this. I can use the same format. Total cost equals average fixed cost plus average variable cost. So how do we illustrate this using a diagram? It has the same shape with that of average variable cost, and it is also U-shaped. So this is the average total cost, which is also the same as average cost. So here we have output in units, and then we have costs. Our next cost will be marginal cost. marginal cost. So a marginal cost is that cost is an additional cost that arises, or it is a cost that is increasing the total cost just because of an extra unit that is produced. So the additional cost that is incurred for producing an extra unit. The additional cost that is incurred for producing an extra unit. So in simple words, what is a marginal cost? Like, for example, you may have been producing at, let's say you are producing 10,000 units, and now you are increasing your production to 15,000 units. A marginal cost is that cost which will be incurred for you producing an extra unit. So in this case, our extra units will be 5 units. You want to produce 5,000 units more than what you've been producing. So the costs that are associated with the 5,000 units that you are producing is what we are referring to as a marginal cost. So a marginal cost cannot be incurred where there is no change of output. It only arises when we have changed, and that change is an increase because it is the cost of an additional or producing an extra unit. So how do we illustrate the relationship? So a marginal cost is also U-shaped, just like a average total cost and average variable cost. We can now illustrate the relationship that is existing between the average cost, and this is how it will be like. Relationship between average fixed cost, average variable cost, and marginal cost. And just to add on marginal cost is simply change. It is change in total cost over change in Q. Change in total cost divided by change in Q. That will give you the marginal cost. So change for the table form questions is referring to the difference between the highest and the lowest, or the new and the initial. And if we've been given a function, then change will refer to differentiating that particular function. So what is the relationship between average fixed cost, average variable cost, and marginal cost? I'll explain that using a diagram. So we have output, which is in units. And then we have costs. So we have the average fixed cost. We have the average variable cost. Then we have the marginal cost, and then we have the average total cost. Average total cost. So what is the relationship between average fixed cost, average variable cost, average total cost, and marginal cost? So marginal cost is intersecting with the average variable cost at its lowest point. That is when it is at its minimum, is when we have intersection of the marginal cost and the average variable cost. And then when marginal cost is below the average variable cost, the average variable cost must be decreasing, not increasing. When the marginal cost is below average variable cost, then the average variable cost must be decreasing. And then at the intersection of the average variable cost, at the intersection of marginal cost with the average variable cost, then the average total cost must be at its minimum. At the intersection of marginal cost and the average variable cost, the average total cost must be at its minimum. And then once we have that intersection, when the MC is above the average variable cost, the average total cost is increasing. The average variable cost is also increasing. And then average fixed cost is falling continuously. So as others are rising, this is falling continuously, though it is not able to reach at the x-axis. So we say it is asymptotic, meaning it cannot touch or intersect with the x-axis, neither can it intersect with the y-axis. So this is the relationship between these curves. And that brings us to the end of short-run analysis. So just to give a summary, in short-run analysis, it's a period where at least one factor must be fixed and the other one must be varied. So what are the costs associated with the short run? We have the fixed cost, the variable cost, the total cost. Be able to explain, be able to back up your explanation with the graphs required. And then we also have average cost. So we mentioned average fixed cost, average variable cost. We have average cost or average total cost as well as marginal cost. Be able to explain, and what are the graphs. If they are required in your exams, you should be able to explain, backing up your explanation with the graphs, and then show the relationship that is existing between graphs, both for the costs and the average costs. And that's all about short run analysis. Bye-bye. Let's meet in the next session.